This module covers statics. So statics is the first in a set of 3 that talk about mechanics of materials. So this will be statics, dynamics, and strengths of materials are the next 3 modules. But this one focuses on statics. So you'll have questions on vector analysis, forces. So like be able to break a force down into its X and Y components, or X, Y, Z. Find the resultant. Add forces together if there are more of them, or subtract them, depending on which direction they're going. Know how to find equilibrium situations. So like what is the force that happens at a pin joint or the torque that happens there. Know stuff about static friction, be able to draw a free body diagram, and be able to find centroids and area moment of inertia. So also the trusses. You'll need to know truss problems. So let's take a look at the handbook section. So the handbook section for statics, we'll zoom in here. This section is actually not that long, but it basically has, okay, break down your force into your I and J components. So you can see here, it just asks for I and J. It's probably not going to ask you for anything in 3 dimensions. So you can be pretty comfortable with working in a plane. So to find the resultant, you add the forces together. To find the resolution, that's basically breaking a force into its vector components, so sine and cosine. And then the moments. So the moment is the same as a torque, and that is R cross F, where R is the radius vector from the pivot point, and F is the force. So you can work out the cross product, or you can use these formulas if your moment is only in one particular direction. And systems of forces. Basically, because the forces and moments are vectors, you can add the i's, add the j's, and add the k's like that. So to find the area or centroid of an area, length, volume, etc., then you would need to know the mass of each particle that makes up the system and then the distance to that part of it. So the other way to do this is know the area. If it is uniform density, know the area of each part, and you sort of find a weighted average. So like here for the centroid, you would have the centroid for each part times its area over the total area, and that would give you the X centroid component. Same thing for the Y. So then the first moment of area is basically just the integral of the area with respect to the X components, which comes out to be the average, the centroid, times total area. So moment of inertia, there's 2 types of moment of inertia. You can have area moment of inertia, which is commonly used in statics, or you can have mass moment of inertia, which is commonly used in dynamics. So the area moment of inertia comes out with units of meters to the 4. So you would have like an x squared and a y squared and get meters to the 4. And then for the mass moment of inertia, you would have like a kilograms times a meter squared. But statics mainly focuses on this area moment of inertia. And then the parallel axis theorem says that if you're not rotating an object around its centroid, then its moment of inertia is the centroidal moment of inertia plus the distance squared from that axis of rotation times the area. So it basically treats it as itself plus a point mass that's a distance away from the origin, because its centroidal moment of inertia is here, this first thing, and then plus the particle moment of inertia is the second part that's added here. Okay, so here's a diagram illustrating if we wanted to find the moment of inertia of this blob around the x-axis, we would have the centroidal moment plus this dy squared, which is distance from the x-axis to the centroid, square that, and then times by the area. Radius of gyration is the sort of equivalent radius of something that if it was just a particle, you can approximate it as a particle at this radius of gyration away, and then that would be equivalent moment of inertia to the other one that you would find just from its basic shape. So there's a way, it might ask you about that. This is how you would find it. Just square root of inertia over area. Product of inertia, So this is different than moment of inertia, but you can still use parallel axis theorem. You basically just have x and y multiplied instead of x squared or y squared. Friction, this one's different. So basically, the static friction force is less than or equal to the coefficient of static friction times the normal force. If you want to see how much force it takes to make something move, then you would use this coefficient times normal, and that would be to overcome a static friction. But the static friction would be less than that if there weren't any external forces at play or not enough external forces. So for example, if you have a block on a plane and the plane is a little bit tilted and the block is sitting on the plane but it's not sliding, then we know that the friction force is going to be less than or equal to the weight of the block part that's pushing down the plane. So that is actually just a maximum that the friction force could possibly be. It doesn't mean that it's necessarily that much, because friction will never be more than the amount that it is required to be, because friction will never push something in the opposite direction. Like, it will never make it move in the opposite direction. So just know that this is an inequality and necessary inequality, but most cases you'll just be needing to find out what is the maximum friction force, in which case you would use an equals there. Screw threads and belt friction, they probably will not ask you about that. Truss, they will. So look back at your notes for statics, be able to solve a truss either using method of joints or method of sections. And then be able to solve for forces that are in equilibrium. So if you have multiple forces happening, you know system's in equilibrium, then if you're given two of the forces, you can find the third one. These are the actual formulas for the area moment of inertia for different shapes. So if we have base is the width, h is the height, c is the location of the centroid, and xc and yc are the xy coordinates for that centroid. So basically, you just want to find the shape, know what these variables are, and then use the appropriate formula to find whether it's area, moment of inertia, radius of gyration, product of inertia, etc. There are a couple ones that look a little bit different. So here in this parallelogram, they don't have h being a factor. H would be the height. They have a, which is the length of that diagonal side. And then in a trapezoid, a is the length of the top side. So just note that like a is something, a changes, b is generally always the width, and h is always the height, but a will change around depending on the shape of what they're using a to represent. Now this is for all the circular shapes, so similar formulas here, do the same thing. And then this is all for parabolic shapes, which is less likely for them to ask you about, but the formulas are here if you need them. So looking back now at the actual chapter, so there is a statics review here. There's 5 problems worked out, but there's some theory. So I would say go ahead and watch the theory part just to get a good overview of everything. And then when you're studying the problems, like pull the problem up, try to work it yourself. If you're totally lost, then watch the solution. But if you can do it, then just skip ahead and see if you got the answer right. That'll be a little bit faster than watching the whole video all the way through. But also studying your cheat sheet and any problems from when you took the course is really good practice, because there is such a variety of things that they can ask you. But definitely you'll need to know how to solve for something in equilibrium, how to find area, moment of inertia, and how to solve a truss. Those would be the 3 biggest things to know. So then there is the practice quiz, 2 chances on that. There is the real quiz, 1 chance on that, and then the drop box for corrections. So when you finish statics, then that means that you are halfway through. Now, what students who have taken the FE exam have told me is that the first part of the exam ends after statics, which is 52 questions out of the total 110. So it's slightly less than half, but the time is a lot less than half. So the first half of the exam is much easier than the second half. But after statics is when you will get an option to take a break. If you want to eat a snack, go to the bathroom, whatever, that's your only chance to take that break. But once you take that break, you cannot go back and look at questions from before. So if there's anything that you're not sure about, that you want to go, the questions that you flag that you want to go back and look at, go back and do them before you take that break because you won't be able to look at them after. All right, so once you're comfortable with the statics material, then move on to dynamics.